Algebraic expressions often involve fractions. Consequently, it's useful to be able to manipulate fractions. The following simplifications are useful to keep in mind. If you have the fraction negative 1 over 1 or the fraction 1 over negative 1, keep in mind that both of these divisions yield the value negative 1. If you have the fraction negative 1 over negative 1, keep in mind that this division yields the value 1. Finally, anytime you have a variable, recognize that you can always write that variable as the variable divided by 1. So let's practice using this particular fact and this particular fact in the example below. In example 6.9, we're going to find at least 5 equivalent ways of writing this fraction. So if we take 5v over negative 2, I'm going to extract the negative sign. So I'm going to rewrite this first of all as 5v over 2 times the fraction 1 over negative 1. Now, why should this equal this? Well, remember how we multiply fractions. We multiply the numerators and we multiply the denominators. And if you do that here, you are arriving back at this fraction. So, now from this point, there are 2 directions that I could go using this result. So on the one hand, I could rewrite this as 5v over 2 times negative 1 over 1, or I could write this as 5v over 2 times a negative 1. Again, because all of these are the same. So if I take this top approach, now let's multiply these 2 fractions back together. Again, I multiply the numerators, multiply the denominators, and if I do that, I arrive at a negative 5v all over 2. So this is another way of writing this fraction. This fraction and this fraction are equivalent. They're the very same fraction. If I take the bottom approach, I have 5v over 2 times a negative 1. Well, whenever you multiply a quantity by negative 1, you just get the negative of that quantity. So this is negative 5v over 2. So this again is another way of writing the same fraction. Now we can introduce this fact. So let's continue on here. So I could separate out the variable from this fraction. I could write this as a negative 5 over 2 times v over 1. And now I recognize that v over 1 is like the x over 1, so I should be able to rewrite this as just v. So I have negative 5 over 2 v. That's another equivalent way of writing the fraction. If we follow from the lower branch and I separate out v, I have negative 5 halves times v over 1, which is negative 5 halves v. That's another way of writing this fraction. And lastly, if I separate out v from this fraction, I have 5 over negative 2 times v over 1, which is 5 over negative 2 times v. So we've taken this one fraction and we've written it in 1, 2, 3, 4, 5 equivalent ways. So what's to be learned from this example? Well, anytime you have a fraction like this, where you have a negative in the denominator, notice that there are other places where the negative could be located. You could move the negative from the denominator into the numerator, or you could move the negative out in front, as is the case in these two expressions. Also, if your variable is a factor in the numerator, notice that you can separate out the variable in this way. Because terms can also involve fractions, it's also useful to be able to manipulate sums and differences of fractions. Recall that fractions are added or subtracted as follows. If you have a fraction a over c and you add or subtract a fraction b over c, so notice the two denominators are the same, you calculate the sum or difference by simply adding or subtracting the numerators, and the denominator stays the same. So let's apply this to the example below. Example 6.10. Let's go ahead and simplify the following expressions. All of them involve fractions. So let's start with part A. So notice we're taking the fraction 2u over 3x and we're subtracting the fraction 5u over 3x. More importantly, notice that the denominators are the same. So when I subtract these two fractions, I do this by simply subtracting the numerators. And I leave the denominator the same. If I subtract the numerators, I arrive at a negative 3u divided by 3x. Now recall that fractions can be simplified by canceling common factors. Well, notice that in the numerator we could factor out a 3. And that 3 can be canceled, and therefore we're left with negative u over x. Now let's go ahead and look at part B. In this case, we're adding two fractions. More importantly, notice that the denominators of these fractions are not the same. So before we can actually add the two fractions, we have to convert them so that both fractions have exactly the same denominator. We can get the denominator of this fraction equal to 14 by multiplying the denominator by 2. However, if we multiply the denominator by 2, we have to multiply the numerator by 2 as well, so that the resulting fraction is equivalent to the original one. So I'm going to rewrite this as 2x times 2 over 7 times 2 plus x over 14. So notice now that this fraction is the same as this fraction because I could always cancel out those 2's, and if I cancel the 2's, I'm back to the same fraction I started with. So if I simplify the fraction, the numerator is 4x, the denominator is 14. This is added to x over 14. So now I have two fractions with the same denominator. I add the fractions by adding their numerators, and I leave the denominator alone. When I add the numerators, I arrive at 5x, and then this is over 14. Now let's look at part C. If I look at the one fraction that's given to us, notice it's not the same as what we had earlier where we were subtracting two fractions or adding two fractions. This is a single fraction, but notice that this fraction looks like it was the result of subtracting two fractions. In other words, this fraction is more in this form, which means it had to have come from adding or subtracting some other fractions. In fact, we can work backwards. It had to have come from taking 18 over negative 3 and subtracting 6t over negative 3. So let's see if we can simplify from here. 8 divided by a negative 3 is a negative 6. So I have a negative 6 minus, now let's look at this fraction. 6 divided by a negative 3 is a negative 2. So really what we have here is 6 minus a negative 2t. So this is negative 6 plus 2t, and that's in simplified form. Okay, now let's go and look at example D. In this case, we have the quantity 4r and we're subtracting a fraction. Notice that these are like terms. Both terms have a factor of r in them. So we should be able to combine these terms and simplify. In order to be able to combine them, you're going to want to rewrite 4r as a fraction and then perform fraction subtraction. In order to write 4r as a fraction, we can begin by writing it as 4r over 1. Now, to subtract these two fractions, I need to make sure that the denominators are the same. I can change this denominator to a 3 by multiplying the current denominator by a 3, but then I'll also have to multiply the numerator by a 3 as well. So we will arrive at 4r times 3 divided by 1 times 3 minus r over 3. The first fraction simplifies to 12r over 3, and the second fraction is r over 3. So now I have two fractions that have a denominator of 3. To subtract, I subtract only the numerators and I leave the denominator alone. This will give me 11r over 3.